In 1973, on the holiest day of the Jewish calendar, the Israeli Armored Corps nearly ceased to exist. Egypt and Syria launched a coordinated surprise assault with a combined force of more than 6,200 tanks. Israeli crews, outnumbered and outpositioned, held the line on two fronts simultaneously. They won, but they paid for it in destroyed vehicles, shattered battalions, and dead men. When the dust settled, the IDF began asking a question that would take 9 years to answer. What if Israel had built its own tank? A machine designed not in Germany, not in Britain, not in America, but specifically for the terrain, the threat, and the doctrine of a country that could not afford to lose a single crew. What followed was not just a tank program. It was a complete reinvention of what a main battle tank was supposed to be. 5 generations, thousands of vehicles, and a design philosophy that no other nation on Earth has ever fully replicated. This is the complete Merkava arsenal, from the first prototype to the artificial intelligence fighting in Gaza today. But to understand why Israel built what it built, you have to understand what it was driving before. Chapter 1. The Foreign Fleet. What Israel drove before Merkava. For the first 3 decades of its existence, Israel fought its wars in other countries' tanks. The M48 Patton arrived from the United States in the early 1960s, a medium tank with a 90mm gun that was already showing its age when it reached Israeli service. The IDF did what it always did with foreign hardware. It upgraded it, installing a 105mm gun and overhauling the engine. That modified M48 became a substantially more capable vehicle than the Americans had originally delivered. The British Centurion told a similar story. Israel acquired hundreds of them and rebuilt them so thoroughly that the upgraded version earned its own name, the Shot, meaning whip in Hebrew. The Shot received a new 750 horsepower diesel engine, the same 105mm L7 rifled gun that had become the Western standard, and Israeli fire control systems that the original British design had never carried. The Centurion that arrived from Britain and the Shot that fought at the Suez in 1956 and through the Six-Day War in 1967 were essentially different machines sharing the same hull. France contributed the Mk.5 a light tank weighing just 15 tons, fast and agile but lightly armored and armed with a 75mm gun. Israel used it for reconnaissance and infantry support roles, where speed mattered more than protection. When the shooting started in the wars of 1956 and 1967, the Mk.5 was useful. When the Yom Kippur War arrived in 1973, with its dense concentrations of Soviet anti-tank missiles, it was a death trap. And then there were the captured vehicles. Every war Israel fought produced a harvest of abandoned Soviet hardware. T-54s and T-55s seized in the Sinai. T-62s taken on the Golan Heights. The IDF put them all back into service, stripped them of Soviet optics and communications, rebuilt their engines, and turned captured enemy equipment into additional firepower. The obsolete, developed later from T-55 hulls, took this logic to its extreme conclusion, converting a Soviet tank chassis into a heavily armored troop carrier that is still in IDF service today. The problem with every single one of these machines was the same. Britain cancelled the Chieftain deal in 1969 under Arab political pressure. France had already imposed its arms embargo. The United States could shift its position at any moment. Israel's tank fleet depended entirely on decisions made in foreign capitals by foreign politicians weighing foreign interests. In August 1970, that dependency ended. when the Israeli government formally authorized the development of a domestic main battle tank. Major General Israel Tal, known universally as Talik, took command of the program. That captured T-55 fleet pointed toward something Tal understood from the inside. Chapter 2. The birth of the chariot. Merkava Mark I and Mark II. Tal's first design decision separated the Merkava from every other tank on Earth. He put the engine in the front. Every Western MBT, the M60, the Chieftain, the Leopard, the XM1 that would become the Abrams, placed the engine in the rear. Tal placed 900 horsepower of Teledyne Continental diesel between the crew and the enemy, using the power plant as an additional layer of armor. The crew compartment sat in the rear, accessed through a back hatch that could accommodate infantry, wounded soldiers, or ammunition resupply under fire. It was not a fast tank. Its power-to-weight ratio of approximately 14 horsepower per ton was modest. That was a deliberate trade. In a nation of the size of New Jersey, every tanker who survived to fight again was worth more than a few extra kilometers per hour. The Merkava Mark I entered service with the 7th Armored Brigade on February 20, 1979. Its main armament was the 105mm M68 gun, a derivative of the British L7 that Israel already knew well from its Centurion modifications. The fire control system included a laser rangefinder connected to a ballistic computer, giving it a first-round hit capability at ranges beyond 5,000 yards. A 60mm mortar rounded out its close support options. 250 Mark I tanks were built before production shifted to the next variant. The combat debut came in June 1982 in Lebanon. Israeli armored columns drove north to confront PLO forces and, inevitably, the Syrian army. At Sultan Yaqub on June 10th and 11th, Merkava Mark I crews engaged Syrian T-72s, the most advanced Soviet tank then in the region, in direct combat. Several Merkavas absorbed multiple hits and remained in the fight. The rear hatch, which no other tank in that engagement carried, was used to evacuate wounded from vehicles that had taken penetrating rounds. The design worked. But Lebanon also exposed problems. The 60mm mortar required a crew member to partially expose himself to operate it. A specific weak spot existed beneath the rear of the turret bustle, and new Hezbollah anti-tank tactics, developed specifically to defeat Israeli armor, were already evolving in the background. The Merkava Mark II entered production in 1983 to fix what Lebanon had broken. The mortar was relocated and redesigned to load and fire entirely from inside the hull, a change so significant it altered the entire crew operational concept. Additional composite armor packages were applied to the turret sides and hull front. A new Israeli-designed transmission extended operational range by 25%. The fire control system was upgraded to the Matador Mark II, with a new NDYAG laser rangefinder and improved ballistic computer. 580 Mark II tanks were built through 1989 at a unit cost of $1.8 million. In 1987, 3 Merkava tanks were destroyed by Hezbollah using double warhead-shaped charges, tandem rounds designed to defeat composite armor by firing a first charge to defeat the reactive layer and a second to penetrate the hull beneath. The IDF responded immediately with a modular applique armor package called Dor Dalet, meaning fourth generation, which was applied to Mark II hulls and became the foundation for every future Merkava protection upgrade. The lesson was absorbed and built into the next design from the beginning. That new design went bigger in every direction. Chapter 3. Israel's own gun, the Merkava Mark III and its variants. The Merkava Mark III entered service in December 1989 and was the first Merkava that did not share its fundamental architecture with the machines that preceded it. The design team, working under Mantak, the Merkava Tank Office, started with a new priority: build the gun in Israel. The result was the IMI 120mm Mk.5 smoothbore cannon, the first tank gun designed and manufactured entirely in Israel. It drew on the German RH-120 lineage, but was adapted to Israeli specifications and tolerances. The switch from 105mm to 120mm reduced the ammunition load from 62 rounds to 46. But the new gun fired all standard NATO 120mm ammunition, including the Elahat, a gun-launched anti-tank guided missile developed by Israel Aerospace Industries. The Layhat could reach targets at over 6 kilometers. Its stated probability of hitting an attack helicopter exceeded 65%, making the Mark III the first non-Soviet production tank in the world capable of engaging helicopters with a guided weapon fired through the main gun barrel. The engine was upgraded to the AVDS 1790-9AR, producing 1,200 horsepower. Fuel capacity reached 1,100 liters, giving an operational range of approximately 500 kilometers. The new hydropneumatic suspension was designed specifically for the rocky terrain of the Golan Heights, with track rollers stripped of their rubber tires because the basalt rock simply destroyed them. The suspension travel reached 600 millimeters total, giving crews a substantially smoother ride over broken ground than any previous variant. Between 1990 and 2003, Israel built between 480 and 680 Mark III tanks, depending on the production batch counted. Unit cost had risen to $2.3 million, a 28% increase over the Mark II. In 1995, the Mark III Baz variant introduced the Barak Zohar, meaning bright lightning, fire control system. The Baz added a panoramic thermal commander's sight, enabling true hunter-killer engagement, where the commander identifies and designates a new target, while the gunner is still engaging the previous one. The Mark III Baz variant, updated in 2000, incorporated the full door-delete fourth-generation armor package across both hull and turret. The Mark III also spawned a low-intensity conflict variant, the LIC configuration, introduced in the early 2000s for operations in Gaza and the West Bank during the Second Intifada. It added belly armor for mine protection, mesh screens over optics and ventilation ports to defeat RPG fire, additional cameras for 360-degree situational awareness, and a remotely operated M2 Browning heavy machine gun positioned above the main gun. The LIC package reflected a new reality. The Merkava was no longer fighting Syrian armored divisions on the Golan Heights. It was fighting in urban streets against fighters who had studied every centimeter of its design for weaknesses. In 2006, those weaknesses became visible again. During the Second Lebanon War, Hezbollah employed Russian-supplied Kornet anti-tank guided missiles and RPG-29 tandem warhead rockets in coordinated ambushes against Israeli armored columns operating in narrow valleys and urban terrain. The Mark III suffered the heaviest losses of any Merkava variant in a single conflict. The IDF's response was not to redesign the armor. It was to make the threat stop before it hit the tank at all. The solution came from a company that had been working on it for years. Chapter 4. The Shield That Changed Everything. Merkava Mark IV and Trophy. Development of the Merkava Mark IV had begun in the early 1990s. Its existence was publicly confirmed in 2002, and the 1st Battalion reached operational status in 2004. From the outside, it looked like a heavier, more angular version of the Mark III. From the inside, it was a different machine entirely. The engine was the MTU 883 Ka500, a German V12 diesel producing 1,500 horsepower, a 25% increase over the Mark III, coupled to a Renk HSWL 295TM 5-speed automatic transmission. Maximum road speed reached 64 kilometers per hour. The main armament was the upgraded 120mm IMIMG 253 smoothbore, capable of firing higher-pressure munitions, and the Elahat guided missile, with an electrically operated 10-round ready magazine that could semi-automatically select ammunition type. The all-electric turret drive, developed by Elbit and Elop, eliminated all hydraulic fluid from the crew compartment entirely. Hydraulic fires from penetrating rounds had been a primary cause of crew fatalities in tanks worldwide for decades. In the Mark IV, that failure mode was designed out of existence. The rear compartment grew. The Mark IV could carry 8 infantry soldiers, a command group, or 3 stretcher patients in addition to its 4-man crew. In combat in Gaza, that capacity would prove its value in ways the original designers had anticipated, but hoped never to need. The Raphael Trophy Active Protection System, known in Hebrew as Meil Ruach, or Windbreaker, was first contracted in 2007. Israeli government certification was granted in 2010. Trophy uses 4 flat-panel ELTA EL/M-2133 radar antennas mounted at the corners of the turret, providing full 360-degree coverage. When the radar detects an incoming anti-tank round, guided missile, or RPG, it tracks the threat, calculates the optimal intercept point, and fires a small explosive countermeasure that destroys the incoming projectile at a safe distance from the hull. The entire sequence from detection to intercept takes milliseconds. On March 1, 2011, a Merkava Mark IV, equipped with Trophy, successfully intercepted an incoming anti-tank missile near the Gaza border. It was the first confirmed operational use of an active protection system to defeat a real combat threat anywhere in history. By the time Operation Protective Edge began in 2014, Trophy-equipped Mark IVs were performing interceptions on a near-daily basis. Over 3 weeks of high-intensity urban fighting in Gaza, the system intercepted Cornet-guided missiles, RPG-29 rockets, and Métis ATGMs. Not one defended vehicle was penetrated. 0 false alarms. Giora. Katz of Raphael called it a breakthrough because it was the first time in military history that an active defense system had proven itself in intense fighting. By 2016, Trophy was operational on every Mark IV in the IDF's 401st Armored Brigade. By 2023, Raphael was producing 40 complete systems and 500 individual countermeasures per month. The Mark IV-M Windbreaker variant, which integrated Trophy as standard equipment, was also fitted to the Namer. The Namer, whose name means leopard, and is also an acronym for Nagmash Merkava, or Merkava APC, removes the Mark IV turret and installs a reconfigured troop compartment carrying 9 fully equipped infantry soldiers. Its combat weight of approximately 60 tons makes it heavier than the tank it is derived from. Its protection level is considered superior to any other armored personnel carrier or infantry fighting vehicle in service anywhere in the world. The Mk.5 7.62mm machine gun is fitted as standard secondary armament, along with the Mark 19 grenade launcher and a remotely operated M2 Browning 50 caliber in various configurations. The Namera, the armored recovery variant, uses the same hull to provide battlefield extraction for damaged tanks without exposing a lighter more vulnerable recovery vehicle to the same threats. The Sholef, a 155mm self-propelled howitzer mounted on a Merkava hull, never made it past two prototypes built by Soltom Systems between 1984 and 1986. The Camp David Accords had temporarily reduced the perceived threat level, and the program was cancelled before production began. It remains the Merkava family's most significant road not taken. By 2005, the Mark IV had replaced the last M60 Pattons and Centurion derivatives in IDF frontline service. The foreign fleet was finally gone. But the engineers had already been working for years on what would come next. That next step started not with armor, but with a helmet. Chapter 5. The AI Tank, Merkava, Mk.5 Barak. In September 2023, 50 years to the month after the Yom Kippur War that had made the Merkava necessary, the Israeli Ministry of Defense delivered the first units of the Merkava Mark V to the 52nd Armored Battalion of the 401st Brigade. The new tank had a name, Barak, meaning lightning. Defense Minister Yoav Gallant called it an extraordinary leap forward that would guarantee the IDF's qualitative advantage in both defense and attack. He was not talking about a new gun or a new engine. The Barak retains the same 120mm Mk.5 smoothbore cannon as the Mark IV and the same 1,500 horsepower MTUV-12 diesel. The revolution is not in the steel, it is in the silicon. Development began in 2018, 5 years before the public unveiling, with the Armored Corps defining requirements drawn from every combat operation since 2006. The lessons of the Cornet ambushes in Lebanon, the RPG coordinations in Gaza, the urban environments where threats came from multiple elevations simultaneously, all of them drove the specification. The result is a tank whose primary advancement is cognitive, reducing the time between detecting a threat and killing it by offloading the heaviest part of that process onto artificial intelligence. The Elbit Systems Iron Vision helmet is the most visible element of that change. Modeled directly on helmet-mounted display technology developed for Israeli fighter jet pilots, it gives the tank commander a full 360-degree synthetic view of the battlefield generated from cameras mounted across the vehicle's exterior. The crew member can see through the armor. The helmet overlays AI-processed target identification and real-time threat data onto that view. The tank can be fought with all hatches closed, in darkness, in smoke, in urban terrain, where threats appear and disappear in seconds. The cognitive load on the crew, the gap between what they perceive and what they need to act on, is narrowed to a degree that no previous generation of armor could approach. The fire control system has been completely replaced with a new architecture featuring multi-touch screen interfaces designed specifically for young conscripts. Elbit's engineers spent 2 years adapting the interface around the experience of soldiers who grew up with smartphones and gaming systems, not Cold War-era analog controls. The principle was to make the most complex targeting system Israel had ever put in a tank feel intuitive to a 19-year-old on his first operational deployment. The trophy system has been upgraded with what is referred to as a silent mode, adding Othello-optronic sensors to the radar suite, allowing threat detection without active radar emissions that could reveal the vehicle's position. The MAJ 7.62mm and M2 Browning 50 caliber secondary weapons remain, along with the internally housed 60mm mortar and the 120mm main gun capable of firing Lahat guided rounds to 4 kilometers. The armament package is unchanged. Everything around it has been rebuilt. The Barak integrates with Torch, the Israeli Land Forces battle management system, allowing real-time sharing of target data, threat locations, and intelligence between individual tanks, dismounted infantry, aircraft, and command nodes across the entire operational area. Elbit's eLINX software-defined radios enable that sharing without the bandwidth limitations that constrained earlier battlefield networks. The tank knows where every friendly unit is. It shares what its sensors detect with everything else on the network. The information that once lived only inside one vehicle's crew compartment now flows instantly to every platform connected to the same system. By 2024, the Barak had been assigned to acceptance trials with the 401st Brigade. IDF reporting from the early phases of the Gaza ground operation indicated the system was performing as designed, keeping casualties to a minimum in some of the most complex urban combat terrain any armored force had operated in since the Second World War. The OFEC and Parag conversion programs for decommissioned Mark II and early Mark III hulls continued in parallel, repurposing older platforms as armored engineering support vehicles rather than scrapping chassis that retained significant structural value. Nothing is wasted. Conclusion. The principle of the chariot. From a 900 horsepower diesel and a borrowed 105 mm gun in 1979 to an artificial intelligence system that allows a commander to fight with closed hatches using a fighter pilot's helmet in 2023. The Merkava family covered in 5 generations, a distance in military engineering that most nations never travel in a century. The M48 Patton, the M60, the Centurion Shot, the AMX-13, the captured T-54s and T-55s and T-62s, all of them were foreign solutions to Israeli problems. Every one of them depended on a political relationship that could be severed at any moment. The chariot, built from Soviet hulls on Israeli soil, was the last expression of that dependency, a final improvisation before the indigenous program matured enough to replace everything. The Merkava Mark I replaced the dependency with a philosophy. The Mark II tested that philosophy in combat and adjusted it. The Mark III proved Israel could build its own gun. The Mark IV proved Israel could solve problems that the rest of the world's tank designers had not yet recognized as problems. The trophy system, developed on the Mark IV, has since been adopted by the United States Army for its M1A1 and M1A2 Abrams tanks and tested on Bradley fighting vehicles and Stryker APCs. An Israeli solution, born from specific Israeli losses in specific Lebanese valleys, is now the global standard for active tank protection. The Namer carries the same logic to infantry. The Barak carries it to the domain of information. In a country of 9 million people, the principle has never changed. The crew comes home. The tank is replaceable. The people inside it are not. That principle drove every design decision from the front-mounted engine of the Mark I to the AI-processed iron vision display of the Barak. And given what is currently operating on the roads outside Gaza, it is not finished yet.